Last question, question 10. This question is about pressure. We've got some windows in an aeroplane. They are windows with shutters so you can have some sleep. The aeroplane is high above the Earth's surface. The atmospheric pressure outside, so outside here, is 23,000 pascals. The air pressure inside the plane is 80,000 pascals. So we've got a higher pressure inside the plane than outside. Not a surprise, there's not very many air particles outside the plane, which is ultimately you open a door. That is why you'd get sucked outside of the plane. Calculate the pressure difference inside and outside the aeroplane. So you've just got to take those two numbers away from each other. 57,000 pascals. The next one, so we've got our Professional Football Association. It says calculate the size of the force. So we can see I want F on its own, so I'm going to have to multiply both sides by the area. So it says use the equation. So we know F equals P times A. So meter squared, pascals. This is just checking that you know a pascal is newtons per meter squared. Want that in newtons, perfect. We don't need to change any of those. So F equals P times A, 80,000 times 0.094 is 7520 newtons. On the same aeroplane, a different window has a smaller surface area. Explain how the force due to air pressure inside the cabin differs. Well, the air pressure is going to be the same. All right, we're not going to change the pressure inside the plane. So if we now look at this, well, we know F equals P times A. If this is staying the same, if I was to reduce the area, it's going to reduce the force. Okay, that's why small windows are used in things like submersibles. Small windows are better than big windows. So explain how the force due to air pressure. Well, we're going to use the equation F equals P times A. We're going to state the pressure is going to be the same. And therefore, if the area goes down, the force goes down. So the force is less on a small window. The pressure is the same. And F equals P times A. Last part, we've got a cross section through the plane. Here's the window. And it says draw an arrow to show the resultant force. So we just need to know all the forces are 90 degrees or perpendicular to the surface. So 90 degrees to it, done. And it's got to be inside because we're showing the air pressure inside the cabin. So it's got to go that way. Okay, next one, we've got a graph. Height and pressure. As we know, as you go higher and higher up in the Earth's atmosphere, the pressure goes down because there's less particles, they're less dense, and there's a lower weight of air above you because there's less air. Describe how the atmospheric pressure changes. Use data to support your answer. So whenever this comes up, pick a change and do that same change twice. So for example, I'm going to pick 5,000, and you'll see this in my answer. I'm going to pick 5,000 here, and I'll pick 5,000 over there, and I'll measure that change to prove that it's not linear. If it was a linear relationship, this would be the same as this. So our first part is describe the relationship. So as height increases, pressure decreases. You can use the full things on your axes. It's a non-linear relationship, and then we're going to pick that data. So if I change from 0 to 500, that goes down by 40 kilopascals. You can see I've just measured that there. If I do the same change here, we can see that's a change of 8 pascals. So not very much. And you can pick a place, as long as you measure 5,000, pick it where it's easier to measure the y-axis. And suggest one reason why the atmospheric pressure changes with height. So the air is less dense as we go higher up. There's a smaller weight in the column of air above you. There's less air above you, and therefore there's less weight of air above you, or atmosphere above you. That's the end of that paper.